Welcome everyone. The last video you saw was a redox reaction in which you were balancing under acidic conditions. This time we're going to go ahead and balance a redox reaction under basic conditions. Now if you recall, under acidic conditions there is at your disposal water, since everything is taking place in water, as well as hydrogen ions. Now when we do a basic reaction, you're going to have also in similarity, you will have water, but this time you will have hydroxide at your disposal. Now, one technique that I'm going to show you is that you can balance the reaction using the same rules as you applied under acidic conditions, and then there's an extra step that we're going to add later on where you neutralize the hydrogen ions by adding the hydroxides that are available. And what you're going to learn in this neutralization is that when you add hydroxides to neutralize the hydrogen ions, they will react to form waters. So we're going to take a look at that. Now, your textbook stresses that you could do this step right after you balance the hydrogens. Now, I will show you that, but I'm going to also show you where I balance under acidic and then I do the new step at the very end, and that might make it easier for you. So here we have an example, and as we always do first is we want to split the two reactions into half reactions, and you can see that these two go together. And when we do that, we also want to assign the oxidation states to each. So we have here cyanide is paired up over here. We have CNO. And here, usually if you see carbon with a nonmetal, most of the time carbon is +4. So I'm going to actually look for the nitrogen here. I'm going to call it X. So I'm going to say carbon is +4. I'll call nitrogen X, set it up equal to -1. And then X is going to be -1 minus 4, which makes the nitrogen a -5. So the carbon here is +4. And we'll call the nitrogen here -5. Now let's see over on this side. We'll call the carbon 4. We'll call the nitrogen X again. And then the oxygen is usually -2. We'll set that up equal to -1. And we'll go ahead and solve here. We have X. And then we have here the 4 here and the -2. That's basically a +2 here. So we combine that and then do the rest of the algebra. We'll see that X is going to be -3. So the carbon remains at 4. The nitrogen is at -3. The oxygen's at 2. Let's focus on the nitrogen. The nitrogen is the one going from -5 to -3. So you'll notice it's becoming less negative. Okay, so when we split this up, and I'll show you this here, notice that that's your oxidation. We saw the nitrogen going from -5 to -3. Now let's go back here and let's take a look at the magnesium in permanganate. And as you know, we'll call manganese X. There are 4 oxygens, each -2, and we'll equal that to -1, which we know doing the algebra, this is -8 over here. And X is basically going to be -1 plus 8, so X is 7. So the manganese has a +7 on the left, so we'll put a little +7 here. And then let's find out what manganese is in MnO2. We'll call it X. So there's 2 of these guys. Oxygen's at -2. We'll equal it to 0 because it's neutral. And we know that X, this is a -4 here. So X is going to be 4. So notice we got the manganese going from +7 to +4. So if manganese is going from +7 to +4, it's becoming less positive, and that's why it's under reduction. So now we have the two half reactions. Now the next step, and we can go ahead and do this right over here. Okay, so I'm going to put the first half reaction on the bottom here. And you always balance elements that are neither hydrogen nor oxygen. So that one's already balanced. And then if you look at the other half reaction, which I'll write over on this side, we can see that that is also balanced. So the only one we got to look at now is oxygen. There's an oxygen over here on the right side. So what we do is when you balance oxygen, you add a water on the opposite side, and we did that. And if you look over here, I noticed I wrote this wrong, so let me fix that. Notice there's 4 on the left and only 2 on the right. So we're going to need to add 2 waters on this side to fix that part. So now the oxygens are balanced. So what we need to do now is balance the hydrogens by adding hydrogen ions, because we're going to do this as if we were doing this under acidic conditions. So let me make a little division here, and I'm going to need to add 2 hydrogen ions because there are 2 hydrogens here. And then on this side there's 4, so I'm going to add 4 hydrogen ions on that side. So we have that fixed. So now we have all the elements fixed. Now, if we were following the way the textbook does it, this is the step where you would now balance, or not balance, but you would neutralize the hydrogen ions. I mentioned earlier that if you have hydroxides and you add hydroxides to hydrogen ions, they neutralize each other and form water. So I'm going to go ahead and show you what's done, but I am going to warn you that I'm going to leave this till the end. I think it's a little bit easier. But you're going to see in the next slide that 2 hydroxides are going to be added here to balance that. You'll see how that forms eventually 2 waters, and you'll see that 4 are added over here, and that will eventually produce 4 waters. Now, I'm going to go ahead and show you this. It's done here. Here are the 2 added to this half reaction, and you can see the 4 added to this half reaction here. And I'm going to, if you want, pause this so you can see the steps. Okay, but I'm not going to do it this way. What I'm going to do is I'm going to go back to where I had it, and I'll let you take a look at these, the progression here. Now I'm going to go back, and I'm going to show you what I'm going to do here. Let me erase this part. I am not going to balance using hydroxide yet. What I'm going to do is now that all the elements are balanced, I'm going to balance the charges. And if you notice, this is neutral down here. This is a -1. This is a -1, and there's 2 positives here. So this side is -1 as a net charge. This side is +1 as a net charge. So you want to add electrons to the more positive side. So we're going to add an electron to the to the product side. And I know I don't have a lot of room here, so I'm going to add 1 electron over here. I'll rewrite that later on, but I am going to add an electron over on this side here. So we have 1 electron. Now, on the other half reaction, there's a +4 here and a -1 here. So the net here is +3. And then on the other side, both of these are neutral. So if you look over here, you're going to notice this side is 0. Now, I did notice I made a mistake here. I need to go back for a minute. This is +1 over on this side. And there's a correction I need to make. And this is -1. The difference between +1 and -1 is 2 electrons. I put 1 electron inadvertently. I need to add 2 electrons to this side, because if you add 2 electrons here, both sides have a -1 charge. So I needed to make that correction at the moment. Now the other one, the more positive side, is the reactant side. It has +3, while this side is 0. So I'm going to add 3 electrons to this side. So I needed to make that correction. I had inadvertently put one electron on the left. Now I've balanced the charges. So we now have everything balanced, the elements and the charges. Now recall, what they did here was they already did the basic solution. What I did is I'm balancing as if it was done under acidic conditions. So if you notice, here are the two half reactions. I wrote them on the bottom. Okay, you can ignore the top for the moment because that is if you balance using hydroxides at an earlier step. Later on, if you want to pause that and if you want to do it that way, you have the process there. The goal is, after you finish balancing, you gotta ensure that the electron numbers are the same. Notice one has 2 on the product side, while the other one has a 3. So what we need to do is, we need to make them the same. So what I'm gonna do is, I'm gonna get this equation, and I'm gonna multiply it by 3, because the least common multiple between 2 and 3 is 6. And then I'm gonna multiply the other one by 2. Now, when you do that, I'm going to go ahead and distribute the 3. And you distribute it to everything. This becomes a 3. This becomes a 3. This becomes a 6. Okay? Then this becomes a 3. And this becomes a 6. On the bottom, we're going to multiply by 2. So this becomes an 8. This becomes a 2. This becomes a 6. This becomes a 2, this becomes a 4. And then what we're going to do is we're going to combine the elements. And if you see things on opposite sides, they cancel. Now notice, this is on the left side of the arrow. This is on the right side of the arrow. So they're going to cancel. Now notice how there are 3 waters on the left side here and 4 on the right side. So what's going to happen is these 3 are gone, and we're going to be left with 1 water here. Okay? So 3 out of 4 got canceled out. Same thing's going to happen with the hydrogen ions. There are 8 over here and 6 over here. So these 6 are gone, and you're going to be left with 2 hydrogen ions. Now, as far as I could tell, there's nothing else here that cancels. So what we're going to do is we're going to write down what remains. So we can see that there are 3 cyanides. We have also, the order here doesn't matter, but we got 2 hydrogen ions. We have 2, what is the permanganate ion. And all of those are on the reactants when you combine. And then we have 3 CNOs here. We have 2 MnO2s. And we have a water. Everything else got canceled out. So this would be the answer if we were balancing it under acidic conditions. Now what we're going to do is I'm going to show you how to do the additional step to convert it from acidic conditions to basic conditions. So the answer that we got here, I'm going to go to the next page. You can see this is what we just got. This is our answer. And what we're going to do is, instead of verifying right now, which under acidic conditions, here everything is balanced. What I'm going to do is I'm going to show you how to change it to basic. So under basic conditions, we are now going to have at our disposal hydroxide ions. So here's what you do. Identify where the hydrogen ions are. And what you're going to do is there's 2 of them. So we're going to add 2 hydroxides to that part. Now, here's the key. Like in math, whatever you do to one side of the equation, you must do to the other. So if I add 2 hydroxides on the reactant side, I need to add 2 hydroxides on the product side as well. Now, what's going to happen is over here, remember that hydroxide and hydrogen ions combine to form water. I shouldn't put an equal sign, but they combine to form water. So what's going to happen is you still got your 3 cyanides. This is going to become 2 waters over here. And then you got your 2 MnO4. And then look what happens on this other side. On the other side, you got, this is still intact. You still got this one over here. And you got a water over here, as well as 2 hydroxides. But what's going to happen is, this water here and one of the waters over here are going to cancel out. So there's going to be no waters left over. So I'm going to do something here to rewrite this. I'm going to erase this water. It's going to be gone. In fact, let me put the hydroxide there so it's not hanging on the bottom. The 2 hydroxides that I put. And then you're no longer going to have 2 waters on the left. You're only going to have 1. So I'll just put 1 water here. And that happened because the 2 waters made here and the water over here, they canceled. Okay? Now, we're going to balance this, or we're going to check if it's balanced, and we have now the verification up here. Let's look at the elements. I see 3 carbons here with the coefficient and 3 here, so that one's good. There's also 3 nitrogens here and 3 nitrogens there, so that one's good. I see 2 manganeses over here and 2 manganeses over here, so that one's good as well. I got here 8 oxygens plus 1 more, so there's 9. And on this side, I got 3 and 4. That's 7, 8, 9. So we got 9 oxygens on each side. And then for hydrogen, we got 2 over here and 2 over here. So that's balanced. So then the last thing we need to do is check the charges. Now remember, there are 3 negatives here. This is neutral, and there are 2 negatives here. So this side over here has a net -5 charge. Now over here there is a -3. This is neutral, and this is a -2. So we also have a -5 charge. So this answer in the blue would be the answer under basic conditions. The previous answer with the black ink would be the answer under acidic conditions. So what you do is you add hydroxides, and you could do this at the end, and that's how you convert from acidic to basic. So we're going to try this problem here. So here we're going to do the same things. Let's split this up. We know these 2 are going to go together and these 2 are going to go together. So when we do a half reaction, we got H2O2 becoming oxygen. The other half reaction is going to be ClO2 becoming ClO2 negative. And what we have here, if we want to assign the oxidation numbers, we can, you're going to see this is a peroxide over here, okay? I'm going to prove this to you. We have, let me use a different color here. Let's say we got 2 hydrogens. I'm going to call hydrogen +1, because hydrogen is positive when it's with another nonmetal. Let's put here, there's 2 oxygens. We don't know the value of oxygen. We'll call it X. When you do the math, you got 2 plus 2x is equal to 0. 2x is equal to -2. So x is going to be -2 over 2. X actually is going to be -1, and that's because the oxygen is a peroxide here. And notice that oxygen is going from -1 to 0. It's becoming more positive. So this is going to be your oxidation half reaction. And then on this side, we'll call chlorine X. There's 2 oxygens. Each oxygen's -2, equal it to 0. So X plus -4 is equal to 0. X would be equal to 4. So here chlorine is +4. Oxygen is -2. And then over here, we'll call this X. There's 2 oxygens, but we're going to equal it to -1. So X plus -4 is equal to -1. X is equal to -1 plus 4. X is +3. So you could see here that chlorine is becoming less negative. So this half reaction is your reduction. Just like that, okay? Okay, so now we're going to go ahead. I wrote them here. Let's follow the steps. So there's no elements other than O and H on the first one. On the second ones, the chlorine's already balanced. So we're pretty much at the point of balancing oxygens followed by hydrogens. Well, in this one, the oxygens are balanced on both the oxidation reaction on the left as well as on the reduction reaction on the right. The only thing not balanced is that there's two hydrogens here. So you're going to add two hydrogens over here. Remember, we're going to balance as if it was acidic. This one over here already is balanced, so don't touch it. So we're at the point here where we just got to balance the electrons. Now, this is neutral, and this is +2. So the more positive side is the right side here. So what we're going to do, let me move this over. We're going to add 2 electrons over here. Let's put a little dash here. Okay, and then this side is 0 and this side is -1. So the more positive side is the side on the left. So here's what I'll do. Let me, I'll move this over here a little bit. And I'm going to put here, we're going to add 1 electron over here. And then let me put my yield sign because that's the more positive side. So we're going to bring these together now. But before that, and I'm going to go ahead and write it over here just like this. So we added 2 there. And now over here, we added 1 electron on this side. The electron number has to be the same. So this one's actually pretty easy. All we need to do here is multiply this one by 2. So when you distribute the 2, this becomes a 2, this becomes a 2, and this becomes a 2. And that will allow the electron numbers to go ahead and cancel out. Now, when we bring this back together, you're going to get H2O2 plus 2ClO2 here. On the other side, you're going to have your 2 oxygens, your 2 hydrogen ions, and your 2 ClO2s. Okay? And nothing cancels out here. Now, this would be the answer under acidic conditions. Okay? So here's what we're going to do. We're going to go ahead now, and we're going to convert this to basic. When you convert to basic, remember you have hydroxides at your disposal. Look for where you see hydrogen ions. There's 2 of them. So we're going to add 2 hydroxide ions here. But whatever you do to one side of the equation, you must do to the other. So I must add 2 hydroxide ions to the reactant side. Now, these will combine and neutralize to form 2 waters. Now, I'm looking at this reaction and I do not see anything else canceling out. So what we're going to do now is I'm going to rewrite this and we're going to verify that everything is balanced on both sides. Now, I did leave off the negative here, and I apologize that's the negative from here. So this side and this side are different. One has a charge, one doesn't. It has to be identical. So the one with the charge will not make it the same as the one without the charge. So let's go ahead and verify. So here is the equation, time to verify. And I know the answer is written up here. We're going to check it now. Notice the states of matter are also written, which at the end you can always add that in. All the ones that have a charge are automatically aqueous. So you have these 2 here that are aqueous. Okay? From the original problem, you already knew that he was aqueous here. So was this one. You were told that this one is a gas, and we know water is a liquid. So let's verify. Let's take a look at the chlorines. So we'll use a different color here. There's 2 chlorines here, 2 chlorines here. So we got a check. Now let's go ahead and look at the hydrogens. We got 2 here and 2 here. That's 4. And then we got 4 here. So the hydrogens are check. We got 2 oxygens here and 2 more here. That's 4. Plus another 4. I see 8 oxygens. We got 2 here plus 2 more over here. That's 4. And then 2 and 2 is 4. So we have 8 oxygens on this side. So that looks good. The final thing is the charges. There are 2 negatives here. So let's put -2. This one's neutral. This one's neutral. So this entire side is -2. This is neutral, and then 2 times -1 is -2. So both sides are -2, and that would be the correct answer to this question. So it might be a good strategy to balance it under acidic conditions, and then at the very end, add the hydroxides to convert it from acidic to basic conditions. So that's a recommendation that I have for you. Now we're going to finish up with 2 definitions. There are 2 opposite reactions. The first one is known as disproportionation. And what that is, it's a redox reaction in which the same species is being both oxidized and reduced at the same time. You see, when tin splits, the tin over here is actually getting oxidized because you can see it's going from a +2 to a +4. But at the same time, notice that tin, the same species, is also getting reduced because on the second one, he's going from +2 to 0. It's going to neutral. So when you have a disproportionation reaction, the way you set it up is you set it up into 2 half reactions. So you need to use this one twice. So you do 1 half reaction to the first one, and then you do the second half reaction to the second one because the tin 2 is being both oxidized and reduced at the same time. Now we do have an opposite to this, okay? So disproportionation is when you have 2 products because the same species got both oxidized as well as reduced. Comproportionation would be the exact reverse of disproportionation. Here you have 2 reactants becoming 1 product, and notice that in a comproportionation, 1 species is being reduced to form a product just like that, and a different species is getting oxidized, and it gives you the same product. The way you would set this up would be the same way you would put BrO3 negative, and you would set it up to the 1 product, just like this, okay? And then the other one would be the other reactant to the same product. You set them up equal to the same product. Now, the one on the bottom over here, you're going from -1 to 0, so this is actually your oxidation. You could see you're going from -1 to 0, so it's becoming less negative or more positive. The other one, let me show you here, a bromine, let's call it X, and then so we can find the charge, there's 3 oxygens here, each at -2, set it up equal to 1. So X plus -6 is equal to -1. When we continue doing the algebra, you got -1 plus 6. So you'll see that bromine here is actually a +5. And then it goes to a 0 over here. So he's becoming reduced. So you got your oxidation down here, and then you got your reduction. But in a comproportionation reaction, notice that the one of the species is getting oxidized, and the other one is getting reduced, and they both give you the same product. So it's the exact opposite of a disproportionation reaction. So if you ever have a problem like that, that's how you set it up. And then the rules, the same rules that we use, whether acidic or basic, you apply the same rules and you take it from there. Okay, so hopefully with practice, you will get better at doing these. This is like solving a puzzle. It's just complex because it has many, many steps. So practice will make perfect.